Okay, the last part had to do with talking about accuracy and precision in aging. Now we're going to talk about bias. Bias can affect both accuracy and precision. And whereas in most of our endeavors, we know there's going to be some error, and usually we can deal with random error. If you occasionally age a fish too high or age one too low, as long as those are spread out randomly, it all sort of comes out in the wash. However, a bias, a systematic bias, can lead to a huge problem when you're aging fish. And so now we're going to talk about where does bias creep in and how do we detect bias so that we can try to overcome it. Now, one thing more I want to talk about is bias in aging. Bias, as far as aging a fish, is when you consistently misage a fish. Now, there's always error anytime we measure anything. And if you have random error in your aging estimates, that's not a huge problem. And in any scientific endeavor, we expect some random error. And as long as it's random, then that error does not affect your results. And if you're talking about random error when aging a fish, if you are, sometimes you're a little high and sometimes you're a little low, those can kind of cancel each other out. But in reality, it's much more common to find a bias where you consistently misage a fish in a particular way, and that can have very negative consequences. Random error can be dealt with, but bias causes serious problems, and so we want to avoid bias. It can influence both the accuracy and the precision. For example, if someone always misses the first annulus, and so one person does not recognize, if you didn't validate the first annulus or you don't recognize it, that's going to affect your accuracy. You're always going to give the fish a lower age than what it actually is. And if you've got somebody that always adds one annulus, that one reader is always seeing an extra annulus that other people don't, then that's going to affect the precision, because this one person is always going to have a different answer than everybody else. So one way that we can look at bias in aging is to look at things called age bias plots. It's just a graphical technique that allows us to get a feel if we're incorporating any bias into our reading. It also helps us to find out where that bias tends to creep in. So many different ways you can do this. One way is to plot the mean age of reader 1 versus the age of reader 2. So you're comparing if there's one is biased relative to the other. This is going to talk about precision. You can plot the mean age of one reader versus a known age. That's going to talk about bias and accuracy. You can plot the mean age of a certain reader the first time they read a structure versus the age that they give the second time they read the structure. And this also talks about precision. And do you have a bias as far as your repeatability? So this is one way that an age bias plot, you can look at an age bias plot. We've got the known age down here on the x-axis, and you've got the age that the reader gave on the y-axis. And we have some error bars on each of these points, so the reader, what this means is that the reader saw several age 1 fish, several age 2 fish, so on and so forth. And so this is the mean age they gave for all the age 1 fish, this is the mean age they gave for all the age 2 fish, and so on. And the error bars sort of represent the standard deviation or the spread around that mean. The 45-degree line is given because if there's no bias, then these points should be scattered on this line, which makes sense, right? If there's no bias, that it should be at least parallel to the 45-degree line, but it actually should be on the line, right? If it's parallel to it, but always above it or always below it, then you're always adding or subtracting one annulus, and so you're biased. But if you're on this line, then you are at least not biased. But here you can see that we're getting some bias, that the older the fish is, that this reader is adding extra annuli. So this reader is overaging older fish.